Good morning, students. Today we are going to discuss a new chapter, Electromagnetic Wave. We already know light is an electromagnetic wave. We studied that in wave optics. Light is an electromagnetic wave. Not only light, there are many other electromagnetic waves also. The mobile phone that we are using, it is transmitting and receiving the signals using radio waves. Now, radar is using microwaves. Those are electromagnetic waves. And you have heard about ultraviolet rays, infrared rays, gamma rays, X-rays. All those things comes under electromagnetic wave. So, in this chapter we are going to discuss what is meant by electromagnetic wave and what are its properties, what are its uses. So, let us first see what is an electromagnetic wave. Electromagnetic wave is a wave which is produced due to coupled electric and magnetic field. Both of them are perpendicular to each other and they are mutually perpendicular to the direction of propagation of the wave. The electromagnetic wave is produced by an accelerated charge. When a charge particle is accelerating, the accelerating charge particle will produce a variation in the electric field, which again produces a variation in the magnetic field. So, the variations in electric and magnetic field, they propagate through space even if there is no medium. It can propagate in vacuum. That is called electromagnetic wave. So, the main thing about electromagnetic wave is that here I have just given a figure of the electromagnetic wave which is propagating along the positive x-axis. As the wave is propagating along the positive x-axis, you can see I have marked a wave in the yellow color, that is actually electric field oscillation. Electric field oscillations will be along the y-axis. Wave is propagating along the x-axis. The electric field oscillation is along the y-axis. The magnetic field oscillation is along the z-axis, that is shown by the dark red line. So, here in this figure you can see if the electric field is along the y-axis, the magnetic field is along the z-axis, and both of them are mutually perpendicular to each other always, and both of them are again perpendicular to the direction of propagation of the wave. So, that is called an electromagnetic wave. So, we can write the definition like this: a time varying electric field produces a space varying magnetic field, and a time varying magnetic field will produce a space varying electric field. So, the electric and the magnetic field are the sources of each other. That means, if there is a change in the electric field, correspondingly that will produce a change in the magnetic field. Again, that will produce a change in the electric field. So, electromagnetic wave, this is the definition for the electromagnetic wave. Electromagnetic wave is a wave in which electric and magnetic fields are perpendicular to each other and they are perpendicular to the direction of the propagation of the wave. All the electromagnetic wave travel with the speed of light, that is 3 into 10 raised to 8 meter per second. So, let us see the properties. What are the properties of electromagnetic waves? We will discuss the properties. So, the first property is the variation in both electric and magnetic field occur simultaneously. Therefore, they attain maxima and minima at the same place and at the same time. So, you have to think like this: electric and magnetic field are always occurring simultaneously. So, I can say like this: electric and magnetic field are in the same phase. Their maximum point and their minimum point are always in the same state, same phase. Now, the second point, the direction of electric and magnetic field are mutually perpendicular to each other as well as to the direction of propagation of the wave, that we already discussed. If the wave is propagating along x axis, electric field will be along y axis and magnetic field will be along z axis. Or I can say electric field will be along z axis and magnetic field will be along y axis. That is also possible. Third point, the electric field vector E and the magnetic field vector B are related by the equation C is equal to E0 by B0, where E0 and B0 are the amplitudes of the electric and magnetic field. What is meant by amplitude? It is the maximum displacement. So, the peak value, maximum displacement, or the peak value of the electric and magnetic field is represented as E0 and B0 respectively. And we can give the speed of any electromagnetic wave by using the equation C is equal to E0 divided by B0. And what is the value of C? It is 3 into 10 raised to 8 meter per second. That means 3 lakh kilometer per second. So, in 1 second, all the electromagnetic waves travels 3 lakh kilometers. So, you can imagine the speed is very high. So, that is the maximum attainable speed. The velocity of electromagnetic waves in free space is given by C equal to 1 by root of mu 0 epsilon 0. So, the speed of electromagnetic wave is given by the equation C is equal to 1 by root of mu 0 epsilon 0. What is mu 0? Yes, it is absolute permeability of free space. Now, what is epsilon 0? Yeah, it is the absolute permittivity of free space. And both of them are having a value. You have studied the value of epsilon 0 as 8.85 into 10 raised to minus 12, and value of mu 0 is 4 pi into 10 raised to minus 7. So, when you put those two values in this equation, you will get the answer as 3 into 10 raised to 8 meter per second. Okay. Now, look at the fifth point. The velocity of electromagnetic wave in any material medium can be given by the equation 1 by root of mu epsilon. So, here it was mu 0 epsilon 0. Here I just made 1 by root of mu epsilon, where mu is the permeability, absolute permeability of medium, and epsilon is the absolute permittivity of free space. So, I can write this equation like this. I can write it like this. V is equal to 1 by root of, instead of mu, I can write mu 0 into mu r, and instead of epsilon, I can write epsilon 0 into epsilon r. Therefore, the equation can be written as V is equal to 1 by mu 0 into mu r, or epsilon 0 into epsilon r. You already know mu r is the relative permeability of the medium, and epsilon r is the relative permeability of free space. We have already studied in this equation C is equal to 1 by root of mu 0 epsilon 0. So, if I put that value here, how can I say about V? I can write like this: V is equal to C by root of mu r epsilon r. V is equal to C by root of mu r epsilon r, because 1 by root of mu 0 epsilon 0 I have written as C. So, V is equal to C by root of mu r epsilon r. Okay? So, that is the speed. The electromagnetic wave obeys the principle of superposition. You already know what is meant by principle of superposition. If two waves comes and interfere, their resultant amplitude will be, their resultant displacement will be the vector sum of the displacement of two waves. So, I can say like this, if y1 is the displacement of the first wave and y2 is the displacement of the second wave, then vector y, the resultant displacement vector y is equal to vector y1 plus vector y2. That also I can write like this, vector y is equal to vector y1 plus vector y2. That is the principle of superposition. Now, next point, seventh point, the electromagnetic waves carries energy as they propagate through space. This energy is equally divided among the electric and magnetic fields. So, we can say like this, all the waves carries energy. So, this energy here in an electromagnetic wave, there is an electric field and also there is a magnetic field. So, the total energy will be shared between the electric field and magnetic field. So, you can say like this, the energy density, I write it as small letter u, which can be equal to electric energy density plus magnetic energy density. U is equal to electric energy density plus magnetic energy density. And anybody know what is the equation for electric energy density? Yes, it is half epsilon 0 E square. Therefore, I will write half epsilon 0 E square. What is the expression for the magnetic energy density? Yes, it is B square by 2 mu 0. So, I write half B square by mu 0. So, that is the total energy density of the electromagnetic wave. Okay. Now, the next point, electromagnetic waves can transfer energy as well as momentum to the objects placed on their path. So, they are having energy. So, they can transport energy and momentum. And the equation for momentum is given by P is equal to U by C. Usually you study momentum is m into v, mass into velocity. But for electromagnetic wave is actually photon. The energy of photon is the rest mass of the photon is 0. So, we cannot use the equation m into v directly, and so we have to find the momentum using another expression, which is P is equal to capital U by C. P is equal to U by C. U is the energy. What is small u I have written here? Small u is the energy density. Capital U is the energy. Okay, energy by C. Yes. Now, we will move on to the next point. For the discussion of optical effects of the electromagnetic wave, more significance is given to the electric field. Therefore, electric field is called light vector. So, the electric field is having more amplitude than the magnetic field. Therefore, we will say electric field as the light vector. And the electromagnetic wave do not require any material medium to travel, that we already discussed. The wave can travel through space and the speed is 3 into 10 raised to 8 meter per second. What happens if there is a medium? Still they will travel, but their speed decreases. Okay. And the last thing, the oscillating charge which has non-zero acceleration can produce electromagnetic waves. So, the oscillating charge will produce electromagnetic waves and it should have non-zero acceleration. That means acceleration should be there. Okay. So, those are the properties of electromagnetic waves. And these all electromagnetic waves will show the properties like reflection, refraction, interference, diffraction, etc. All the waves, they show that properties. And these electromagnetic waves does not have any charge. charge is 0. Therefore, the electromagnetic waves are not deflected by the electric fields and magnetic fields. Okay, the electromagnetic waves are not deflected by electric and magnetic field since their charge is 0. So these all are the properties of electromagnetic waves. Hope you have understood this. Thank you.